Hello. Thanks for wanting to learn more about the LYNX Mosaic software framework. In this brief presentation, we'll dive a little deeper into what's in LYNX Mosaic. And it's really, think of it as two elements. There's the MOSA and there's the IC, the modular open standards approach that is being adopted broadly across military, avionics, and federal markets, and the IC, which stands for Integration Center. So what you'll see from us is if there's good third-party technology out there, we'll look at how that can be integrated into our technology as opposed to forcing you to use our technology. We want to reduce program risk, project time cycles, and project costs. So let's dive in. LYNX has spent over 2 decades focused on addressing the needs for military, avionics, and federal markets, whether that's on the ground, whether that's under the water, or whether that's at various levels above the world. And you see some of the examples that we're in, including the Grey Eagle, which is a Xilinx-based platform, ARM, including MH-60 helicopters that have been flying for a lot of years using our operating system. One of our most public recent wins, in this industry, there's only certain things that we can talk about publicly. And in the F-35, our technology's in the panoramic cockpit display, and it's in the integrated core processor platform. And we're proud of that relationship. It has driven our work around DAL-A safety certification for LYNX Mosaic. It has driven the first IPv6 certified stack to DAL-A, and we are incredibly excited about where that Intel-based platform is going to go in the future inside Lockheed. If I asked you to think about one takeaway from this presentation, it's here, where we really want to talk about what we do differently from the alternatives that are out on the marketplace. And it really starts with the foundation of the separation kernel. It's a very, very small piece of code, and it's what's known as a type 1 hypervisor. But we really have to focus on the fact that there is no console, no drivers, no device emulation. So all we're doing in that hypervisor is setting up the virtual machines, isolating those different systems and applications from each other, and then enabling those partitions to have the right permissions of underlying hardware and the right amount of time they need to complete their tasks. So the other way to think about it is control plane, data plane. There is no data plane activity from our kernel. So, unlike a lot of these systems that have recently been broken, where you see operating systems as the main way to get those systems compromised, there is no way that LYNX Secure can be taken over and have memory rewritten, permissions changed. Once these systems are set up, it's set up immutably. And if somebody crashes an operating system on top of the hypervisor, yes, that particular virtual machine will crash and we'll need to reboot. But there is no way for an attacker to get through that operating system and down into privileged code. The other way to look at LYNX Mosaic is the sort of traditional, as I'd call it, the layer cake. So at the bottom of that is the hardware, latest generation multi-core ARM processors, PowerPC processors, and Intel x86 platforms. The hypervisor that I just described, LYNX Secure, sits on top of that. That's responsible for isolating the different virtual machines from each other. And on top of that, we see a range of use cases depending on what customers are wanting to accomplish. We have some people that will only run bare metal code, something we call Lynx Simple Applications, or LSA. Pure bare metal, very small, very deterministic, and basically very high levels of security. We have our own operating system, LYNX MOSA.ic, and that allows you to support DAL-A certification. It has standard APIs like ARINC 653, FACE 3.1 conformance. So your deterministic applications or your software that has to go through safety certification would sit on top of the RTOS. And then we'll see non-real-time applications, you know, the beauties of Linux, the big operating system and ecosystem around it, which really helps, again, collapse development schedules and costs because there's so much software out in the public domain. So building those sorts of systems and optionally connecting them up into the cloud, be that on-prem or public cloud, using that system on the right-hand side up through the Lynx node manager, that's your basic architecture. And, you know, again, depending on how people want to build it, you'll be able to configure those hybrid architectures with, you know, multiple cores running Linux, or just a couple of cores running Linux and running other operating systems like an RTOS or bare metal code on other parts of the hardware. I mentioned earlier that the IC in Mosaic stands for Integration Center. Systems are becoming drastically more complicated. The addition of connected systems means customers have to worry about cybersecurity and keeping their software up to date. The addition of machine learning, artificial intelligence of all forms is greatly increasing the size of code bases. So what we're looking at is how do we bring in compelling complementary technology from third parties, prove it with our own technology, and offer it up to customers as a complete proven package. We have two to talk about as of the moment. There will be more coming out over time. The first of these is from a company called RunSafe Security. They're focused on cybersecurity and in particular around Linux-based platforms. Remember, one of the pieces of Mosaic is Build Root Linux, which allows people to use a Linux architecture and get all the benefits of an ecosystem around Linux and bring it into these mission computers. So one of the main challenges with Linux is there's a lot of known vulnerabilities with Linux, something known as the common vulnerabilities and exposures. You find various databases to cover those. And a lot of those, once somebody compromises the system, they're really focused on corrupting memory, either to stop the system working or to actually change the capabilities and functionality of a system. What RunSafe technology does is it the address layout for your Linux-based applications. So if people are able to compromise the operating system, it's very hard for them to work out where in memory that actual application is, because we've randomized it and split up all the different libraries. So that makes it much harder for people to actually compromise and change the functionality of a system. That's supporting Build Root Linux now, and we're looking at how that technology can be supported with applications running on LYNX MOSA.ic in the early part of 2024. The second third party where we're offering technology as part of a offering from Lynx is Percepio. They have a product called Tracealyzer, and this is really focused on helping customers debug very, very complicated multi-core systems with all sorts of virtual machines going on, how you get down to root causes on performance issues, memory scheduling issues, bugs in a much quicker way than has been done previously. So advanced tracing, tracking of, you know, a whole series of connected events across multiple cores to help you find the root cause and then do something about it. As I say, those are the two today. We intend to add more third-party technologies in the months, quarters, and years to come. Thanks again for listening. I wanted to give you 3 options for follow-up if you want to learn more. The first is we have our resource center. Feel free to pull down blogs, technical articles, and other pieces from there. Secondly, we have our own newsletter. We'll send you materials every quarter or so with what's new and exciting. Thirdly, send me your feedback on this presentation, but also if you want to find something out that wasn't covered, email me and I will get back to you. Again, thanks for listening. My name's Ian Ferguson. I run marketing at Lynx. We greatly appreciate your interest in our technology and our company. Thank you.